So this is our experiment station. With here, this is the surgery setup, and here this is the experimental tank and the electronics, microscopes, and so on. So we're about to start the experiment. Here is the fish alive, as you see. We're gonna anesthetize it and do the surgery. So we're ready to do the experiment. The fish is here in the tank, if you can see it. It's locally anesthetized, it's awake and cauterized so that it doesn't move. And you have a bunch of electrodes around the tank to stimulate and record. And here on the oscilloscope you can see the EOD of the fish. That's the electrical field that it's producing around its body. So we're gonna go down in the brain with the electrode. The noise you hear is the voltage trace from my recording electrode that's hooked up to a speaker, so that spikes will be heard as clicks on the speaker. I'm still not quite close to a neuron, but you can see on the oscilloscope that you have little spikes, so there's neurons in the distance. We'll get closer still. So now I have a cell, I'm close to a cell. This is extracellular recording, so it means I'm not in the cell but just beside. You can see on the oscilloscope here the action potentials, and you can hear them. Those clicks are the action potentials. Now what you'll see here is that I'm going to play a stimulus, rhythmic stimuli, and you're going to hear the cell respond. So the stimuli have different frequencies. This is 1 Hertz, and here you see the amplitude of the stimulus that goes up and down, and what you can see is that the neuron responds at increasing amplitude of the stimulus.